Okay, so I was trying to do it using my Smart Notebook, and unfortunately it wasn't working. So the Notebook file is actually online in the right angle triangles folder. The file itself is completely full, and then this video will really go through all of the lessons in that. So it'll work in parallel, and I'll just sort of read what the notes say because I obviously can't get them on the page as I do this. So the lesson starts off by saying what your learning goals are. So solving for missing sides of an angle in a right angle triangle, okay? Then we move back to just checking some calculator work. Again, the first part is, I'll just write calculator, review. And the first part was really just remembering how to do your calculator. So I think it was cos is equal to 0.1736. And remember, you're going to do second function cos on your calculator. And then plug in the number. So I'm opening your calculator, making sure my calculator is in degrees. And I'm going shift cos 0.1736 gives me an angle of 80 degrees. So angle theta is 80 degrees. And my next one is sine of theta is equal to 0.07. Oh, sorry, excuse me. 0.7071. And when I go second function sine of theta, that gives me 45 degrees. I believe I'm rounding there. And my last one for an example is tan of theta is equal to 0.4463. Again, second function or shift function tan, put in the decimal, and that gives me 24 degrees. Okay, so that's the first part of this, and that's just calculator review. Now we're moving on to actually solving for an unknown triangle. And it goes on about when identifying which trig ratio, you want to know what you have and what you don't have. And then there's a triangle there on the left-hand side. And I'm just going to sketch that triangle really, really quickly. So if I sketch this triangle really quickly, I know it's a right angle triangle. I know this bottom corner is 17 degrees. I know the bottom of my triangle is 30, and the side of my triangle, side leg, is x. Now all of a sudden what we want to do is actually use a trig ratio to solve for the unknown. In our last day, our angle given was always theta, but in this case our angle is going to be 17 degrees. So based on that angle of 17 degrees, we're going to label. So right next to it is our adjacent side, and across from it again is our opposite side. So using SOHCAHTOA, we are going to identify which trig ratio. So you want to use what you have and what you need. So what we have here is we have an angle, so that's good, and then we have opposite and adjacent. So we're looking for which trig ratio uses opposite and adjacent. So sine uses opposite and hypotenuse, cos uses adjacent and hypotenuse, and tan uses opposite over adjacent. So right away I know I'm going to use tan theta is opposite over adjacent. So now I plug in what I know. It's not theta anymore because I actually know it to be 17 degrees. So it's going to be tan 17 degrees. The opposite side, however, we don't know. So we're going to put in the value of x. And the adjacent side we do know is 30. Now, we have a fraction on one side or a ratio on one side and tan 17 on the other. As we know, any number has a denominator of 1. The reason we drop that to 1 is because now we can do Zorro by circling our x and drawing our z. So it becomes x equals tan 17 degrees times 30, then divide by 1. Now this part is you need to be very careful on your calculator, guys, because you actually need to make sure you do tan of 17 and then hit equals before you multiply it by the 30. If you don't do that, it'll actually multiply the 17 by the 31st, and your answer will be incorrect. So here I got 9.17, which means my side length here would be 9.2. And in this case, they actually didn't give us a unit. Let me just see if there's any more examples on this one page. And that was the first example, okay? And again, that's all there on your Smart Notebook file. Okay, let me see if I can jump pages now. Flip to my next page. So now, again, we are using SOHCAHTOA again, from last slide, when you identify the ratio to choose, you need to see where your unknown is and where your known information is. So let's just look at our next triangle, and again, I'm just going to draw it really quickly. So my bottom angle here is 38 degrees. The base of my triangle, even though it's upside down, is 12, and here my diagonal side, which we know to be the hypotenuse, is x. So again, we have to use an angle, and the angle cannot be the 90-degree angle. So the biggest hint there is always the angle given. So based on this 38 degrees, we're going to label the 12 as opposite because it's across from that 38 degrees, and our x is our hypotenuse because it's always the diagonal across from the 90-degree angle. So again, I'm going to write TOA. I told you that yesterday that I always write it. And now all of a sudden we're using opposite and hypotenuse. So sine uses opposite and hypotenuse. I see that right away. So I'm going to set up my trig ratio. So sine of theta equals opposite over hypotenuse. Please make sure you're writing it each time so you don't forget what you're doing. It's not theta anymore because we actually know that that is 38 degrees. The opposite is 12, and in this case, the hypotenuse is our x because it's our unknown. Again, like before, we drop a 1 under the sine 38, circle our unknown variable, and draw our z for 0. In this case, it's going to be x equals 1 times 12 divided by sine of 38. Once we punch this into our calculator, remember, it's just 1 times 12 is 12, and then divided by no second function, nothing, just the sine of 38. Okay, if the supply teacher is there, she can definitely help you with that part if you're not coming up with the same answers that I am. So in this case, I get 19.49, so I'm going to say 19.5. So 19.5. Again, you guys should be following along. In this case, it's meters, because I know they identify as meters. I go back to my drawing, 19.5 meters. Okay, that was my next example in my slides, using sine. I'm on to example C, which is, this is the last one. This one now doesn't have a known angle. So this is back to what we were doing before. I'm going to do my best to draw this triangle for you guys. Okay, right angle triangle up here in the corner, excuse my drawing, alpha in the bottom, the diagonal is 5, and the sort of left side leg is 4. So again, in these examples, we want to identify what we have and what we need. In this case, we have the 4, we have the 5, and we need this alpha in the bottom corner. So I'm going to label everything based off of this alpha. We know that 5 is the hypotenuse because it is across from the 90-degree angle. We know that the 4 is adjacent because, again, it is next to that alpha. So TOA. So now I'm using adjacent and hypotenuse. So hypotenuse and adjacent. What uses that? So sine uses opposite hypotenuse. That one's out. Cosine uses adjacent and hypotenuse. So I'm going cos of alpha in this case is equal to adjacent over hypotenuse. So cos of alpha, because it stays alpha, we don't know what that is equal to adjacent is 4, hypotenuse is 5. These are the best ones to get because all you need to do is go 4 divided by 5. So cos of alpha is equal to 4 divided by 5, which gives me a decimal of 0.8. We know that when we have a decimal, we are going to hit shift or second function and then the ratio to get the angle of theta. So angle theta, I'm going to hit on my calculator shift cos 0.8. And I get an angle of 36.8 degrees or 37 degrees rounded. So that means this angle here is 37 degrees. Sorry, I can't fit it in my diagram because of the way I drew it. Okay, let's jump another page. Hopefully this is new. I don't have to redo it. Okay, we're on to example D in the note. So I'm going to again just draw our triangle here, and alpha is in that top corner. My hypotenuse, or my diagonal, is my 13, and the base there is that 5. So again, we are labeling based off of what we are trying to find, which is this alpha. So across from alpha is 5, so that labels as our opposite. I've already said that 13 is our hypotenuse because it is across from the 90-degree angle. So again, SOHCAHTOA. What uses opposite and hypotenuse? Sine. So sine of alpha is equal to opposite over hypotenuse. Sine of alpha is equal to the opposite is 5 and the hypotenuse is 13. Again, because we're trying to find an angle here, all we need to do is put that 5 divided by 13 into a decimal. So 5 divided by 13 gives me a decimal of, and I'm going to remember that I'm keeping 4 decimal places. So it gives me a decimal of 0.3846. Again, because I want to find the angle itself, I'm going to hit angle alpha, and I'm going to hit second function sine and put in that decimal. Remember, you're doing your inverse of your sine. So this gives me 22.6 degrees, so 23 degrees. And that means that angle alpha is 23 degrees. Let me scroll and make sure, based on these slides, that there isn't any extra for you guys. And there isn't. Okay. Now, I'm on to solving triangles. So, solve a triangle means to find all 3 sides and all 3 angles. You will always be given 3 of the 6 pieces of information. So the first thing that they're giving us is they're saying triangle ABC, where angle B is equal to 90 degrees, angle C is equal to 33 degrees, and side length B is equal to 22. So for these diagrams, you can always just do a quick sketch. It does not need to be perfect. We know that they're telling us that angle B is our 90 degrees. They're saying angle C is 33 degrees. And they're saying side length B, which again is across from angle B, is 22. Again, we want to solve for everything here. So our triangle is ABC, so I label my last. So easiest way to figure out angle A is knowing that all angles in a triangle add to 180 degrees. So we can say angle A is equal to 180, subtract 90, subtract 33. 33, not 30. So angle A is equal to 180 minus that 90 minus the 33. So 57 degrees. Hopefully everyone understands that. Now we're not done though. We need to figure out one of the side lengths. You need to decide which side length you want to find first. If you want to find side length C, that is perfect. So we're going to look for side length C. In order to find C, we need to use angle C. So that means this is going to be our jumping off point, the 33 degrees, which makes C our opposite side and 22 our hypotenuse. So again, we're looking at SOHCAHTOA, and we're saying which uses opposite and hypotenuse. Right away we know it's sine. So that means sine of C is equal to opposite over hypotenuse. Sine of C we know to be 33 degrees is equal to opposite, which is C, we don't know, over hypotenuse, 22. I'm sorry guys, I'm going to run out of room, so I have to go to the side. We drop a 1 and we do our Zorro. I have to come back up over here for my solution, I'm sorry. So C is equal to sine of 33 times 22, hopefully you guys can see this, divide by 1. Remember to do sine 33 equals, then times by 22, divide by 1. So C, side length C is 11.98, so 12. So I'm coming here and I'm saying that this is 12. Okay, now guys, we can use Pythagorean theorem to figure out the third side, because we know that our hypotenuse is our longest. So if I want to figure out side length A, it's going to be A squared equals C squared minus B squared. So A squared is equal to 22 squared minus 12 squared. And then we're going to end up saying A is equal to the square root of 22 squared minus 12 squared. Hopefully you remember this from grade 9. 22 squared minus 12 squared gives me 340, and then I need to take the square root of that. So A, and for lack of a better place of writing it, A is equal to 18. So now I've solved for the entire triangle. So remember, solving for the entire triangle is just solving every angle and every side. I know that there's another example, but I think this video is getting a little long at 15 minutes. So you can go through the other example on your own and give it a try, okay? So that's the end of our lesson, and this is really setting you up to use the trig ratios to solve for a missing side or a missing angle. Bye, guys.